In this video, I'm going to measure the frequency response of a vintage Sanyo Plus Series D45 cassette deck using an oscilloscope and a tone generator on my Mac. The setup's pretty simple. The tone generator will be plugging into my Mac using this 1/8 inch mini plug, and then I'm going to be using this tone generator program here, and then this gray cable is going to be connected to my oscilloscope, which is going to measure the peak-to-peak output of the signal when it's played back. Here's a little diagram of the setup. I've got my MacBook Pro 2019 on the right, where the 1/8 inch mini jack plugs into it. It then goes to the cassette deck input, left channel only, along with the right channel of the Mac coming out and going into the oscilloscope. Because we want to measure the amplitude of what's actually being generated by the MacBook Pro and make sure that that stays level with the input into the cassette deck. I've found that these frequency generator programs, or maybe it's just how the Mac works, as you get up into the higher frequencies above 15 kilohertz, the signal becomes attenuated. So it wouldn't be fair to have an attenuated signal go in and then measuring it coming out and see that it's less and then playing that on the cassette deck. So that would be the recording phase. For the playback phase, we're only going to use the little line on the bottom of the output of the cassette deck to the input of the oscilloscope. That way we can measure the amplitude of the signal for the various frequencies, and we can see how that changes over the frequency. Oh, and we're going to be testing using a metal cassette tape with the bias and equalization set to the metal setting along with Dolby noise reduction. So we're all set here. I've got my frequency generator running at 1 kilohertz, inputting into the cassette deck. I've got minus 10 dB on the input signal strength. We got metal tape with noise reduction on. We're going to reset the counter to 0. We've got 6 divisions peak to peak on my oscilloscope, which is also measuring the output of the signal generator because we want to keep this amplitude the same input into the deck for the different frequencies. If this changes, then that's not going to be a fair comparison on playing it back because the input level amplitude had changed. And we're using this multimeter for the frequency counter. It's showing 999.5 versus the 1000 there. This meter is certified for plus or minus 1.5%. So it's within range, and basically using this we can tell what frequency we're inputting, or when playing back what frequency is coming out of the tape. So I'm going to go ahead and switch this to 20 hertz and start the test. Okay, I've changed everything to 20 hertz, and I'm going to go ahead and record that. And we can go ahead and just monitor as we go up, because that's pretty much it's flat from my signal generator all the way up to about 15 kilohertz. Then I'm going to need to do some tweaking. So let's go ahead and go to 25 hertz. You can see we've got 25 here. Amplitude is still 6 divisions, minus 10 dB on the cassette deck. Let's go to 30. Okay, everything is looking good. Let's go to 35. Everything looks good. 40. Okay, everything is looking good. 45. Looks good. Let's go to 50. Okay, 50 looks good. All right, let's start jumping up 10 at a time. Let's go to 60. All right, 70. 80. And 100 hertz. And we'll adjust our oscilloscope. Okay, now let's start bumping up 100 hertz at a time. Go to 200. 400. 800. And 1 kilohertz. All right, let's start going up 1,000 at a time. Now we're at 2,000. 4,000, 7,000, 10 kilohertz. Let's go to 12. 12 kilohertz, 14, 15, 16 kilohertz, 17 kilohertz, 18 kilohertz, and you can see our amplitude went down a little bit. I'm going to adjust that on the output. So we're back to minus 10 there as well. All right. 19 kilohertz. And we need to try to adjust this as well. That's all I've got. So 19 kilohertz, we've got 6 divisions. And we can try one more to 20 kilohertz. Okay, we're just going to have to remember 20 only recorded at maybe minus 15 here, and we've got 4 divisions because I can't increase the output of my tone generator any further. And just for kicks, there is a 21 I think I can get on here, but it's a little, yeah, pretty much you don't see it on the cassette deck, and we're very low here, and this isn't even picking it up. All right, well, let's go ahead and set this up for playback and see what we got. Okay, so let's begin. We'll see the 1 kilohertz here initially, and 1 kilohertz, 6 divisions, minus 10 on the screen of the cassette deck. Then we're going to 20 hertz, and we can see that's only 2 divisions out, and also minus 20 dB on the cassette deck. So yeah, that is attenuated, which would be expected because this frequency spec was 30 hertz. So we're still at 20. Now we're up to 25 hertz, and now we're about maybe 3 divisions total, peak to peak. And now we're at 30 hertz. And now we're at close to 4 divisions, a little bit less. 35 hertz, we can actually see it went down, surprisingly enough. That seems odd, but that's what happened. Now we're at 40 hertz, 4 divisions. And 45 hertz, we're at 6 divisions, and we're back to the minus 10 on this display. Now we're 50 hertz, we've got 6 divisions, which is good, basically flat. 60 hertz, again, 6 divisions, basically flat. 70 hertz, a little bit of a dip again, interestingly. 80 hertz, basically 6 divisions. And 100 hertz, a little bit more than 6 divisions. Maybe 6.5. And 200 hertz, we're back at 6 divisions. 400 hertz, 6 divisions. 800 hertz, 6 divisions. 1000 hertz, 6 divisions. 2 kilohertz, 6 divisions. 4 kilohertz, 7 divisions. 7 kilohertz, a little more than 8 divisions. 10 kilohertz, probably 9 divisions. 12 kilohertz, maybe 9 or 10 divisions. 14 kilohertz, similar, and we can see it went up here as well. Interesting. 15 kilohertz, 10 divisions. 16 kilohertz, similar. 17, similar. 18, similar. 19 kilohertz, or 9 divisions. And 20 kilohertz, maybe seven-ish divisions. Almost back to the minus 10. And 21, it shrunk down, but it's recording some level there. So it's interesting, but basically we can see that the high end is actually amplified more on the cassette deck than the low end. The low end is pretty flat all along the board, but the high end, that's what really goes and peaks quite a bit. To see what this looks like, I went ahead and entered the frequency and oscilloscope divisions into this spreadsheet. From that, I calculated the dB gain or loss with respect to 6 divisions being the normalized value, and then I created a little graph that shows frequency versus dB gain or loss from the 20 hertz all the way up to 20 kilohertz. So there you have it. We easily measured the frequency response of this vintage cassette deck using a simple oscilloscope and a tone generator program. If you enjoyed this video, please give it a like, and it'd be great if you subscribe to my channel. Also, if you're interested in watching me replace the belts in this Sanyo vintage cassette deck, there should be a link on your screen now that you could click that would take you there. Thanks for watching.